let's do this problem called maximum number of achievable transfer requests. That's what's given to us. We have n buildings, number from 0 to n minus 1. Okay. Each building is a number of employees. Yes. Each transfer season, and some employees want to change the building they reside in. You have given an array request where request I equals to from to represents an employee's request to transfer from building. Okay, so some employee will put in a request. He will say, I want to move from this to this. All buildings are full, so a list of requests is achievable only if for each building the net change in employees transfer is 0. Okay, so if X employees leave building 1, then X employees have to also come into building 1. All right. This means the number of employees leaving is equal to the number of employees moving in. For example, if n equals to 3 and the two employees are leaving building 0, and one is leaving building 1 and one is leaving building 2, there should be two employees moving to building 0, one employee moving to building 1, and one employee moving to building 2, right? So number of leavers should be equal to number of incomers. Return the maximum number of achievable requests. Let's look at some examples. So here this is given from building 0 we have employees. So here what you can do is X and Y want to reach building, leave building 1. So for X, you could just do B comes to building 1. So X and B can meet each other. So Y goes to building 1. Somebody has to leave building 1. A leaves to building 2. And somebody comes to building. So this cycle. Yes, that's what it says here. Like we can achieve the requests of X and B by swapping their places. Right? X and B will just swap each other. And Y, A, and Z. Y, A, and Z, which is this cycle. By swapping the places in the three buildings. Makes sense. So we have to there could consider like number of cycles, make a graph and figure out number of cycles. That could be one way, but like which path to choose. Once you choose a path, you have to choose every option. So for every request, you have to either choose it or not choose it, right? So how many requests are there? So the number of requests are quite limited. The number of requests are limited. I think we have to use that fact. There will be at max 16 requests. The number of buildings is also not that high. Okay, everything is quite small here. So maybe a brute force itself is fine then. So we have to come up with some solution. So let's consider all possible combinations of accepting requests. Like you accept a request, you don't accept a request, right? So for every request R, you either accept it or don't accept it. And then you keep doing that, you consider all the combinations. And then for every combination, you see whether it's a valid combination. Yeah, so for example, you didn't accept any request. That's fair, it's a valid combination. And it's a valid combination and the number of requests accepted are 0. Let's say you request these two accepts only. Again, it's a valid combination, so number of requests accepted are 2. You accept only these three requests, Y to 1, A to 2, and Z to 0. Even that is a valid request of 3. So if you consider 1, 2, 3, 4, 5, all of these 5 requests, if you consider, that's valid. This request can't, if you consider, then it's an invalid combination. So let's do this. Try all combination of requests. How many of these would be there? So it's 2 to the power r. For every request, you have to do that. For each combination, check if it's valid. If valid, update max. I think that's all, right? So a bit is how do you try all the combinations? Let's recursively keep doing it, I guess. Okay, so do it recursively. Okay. And how do you check valid? Well, you maintain. So that's another thing, right? How do you check valid? Maintain incomers and outgoers per building for each combination, right? So maybe save like out minus in for each building. Okay, should be 0 for each building. Okay, so let's define a building state. You have a building state equals to new int of size n for each building yeah, okay, fine. For each building maintain out minus n, right? Now we start from the first request, so you return maximum request. You just, so how what are this change to this and this? So you're saying int maximum request. So you start with this start index and you go with okay, so you go with this building state and then you go with this request array maybe. So you wanna return so you wanna not return maybe okay let's do we don't know how to return first so do maximum requests. Let's make it void. So you do maximum request of starting index is 0, building state initially everything is valid, and then you do request array. And every time when you complete a combination, that would be the case when would be equals to you have checked each and every request. Let's also maintain accepted requests. Also maintain and let's return this guy. So now what you want to do is how do you do that? You check the building state. So is valid is let's say you say true and go through each building. So for each building in building state, if b is not equal to 0, if out minus n is not equal to 0, then well then is valid is false and you break out of this loop. And if is valid, then you do the max accepted request as max dot max of request comma whatever these accepted requests are, right? And then you return. And if that's not the case, then you look at this next and you take two options. Option one, don't accept the request. So in that case, you do just call this function with index plus 1. Same building state doesn't change. Whatever states the buildings were in, the array of requests, and whatever accepted requests were there so far. Okay. And what is option 2? Is accept the request. So if you accept the request, the building state will change. So first change the building state of which building? Well, request start index 0. This is for the building that you're moving out from, so minus minus, and this will show the building you are moving into. So you change the building state, and then you call this guy with this and accepted request +1, right? And you want to backtrack as well, so as to get back to the original state that you were on. So you will do ++ here and minus minus here. Does that sound fair? All right, let's run the code and fix any compilation errors. There are few. Line number 7. You wanna add a semicolon. You wanna return it. Okay, wait a few seconds. Sorry again. Fix more compilation errors. Is it requests? Alright, so basically you tried all combinations, and for each combination check if it's valid. If it's valid, then you see how many requests were accepted in that combination and increment your total max. So that's all.